This video will show you how the three axes and their components all come together on the main metal frame. We begin with the x-axis and the linear guides for the z-axis. These guides fit into the linear bearings on each end of the x-axis. Once they've been placed, slide them in and out and make sure they move freely. If they don't, your linear bearings inside the x-axis might be misaligned.
Next we'll be applying some printed parts. Trim them if there's excess printed material, then assemble them with the cylinder head screws and nylock nuts. Don't tighten too much yet. Clip these printed parts into the linear guides. Place them in the middle of the linear guides so you can easily assemble the x-axis. Notice that each part is identified with a letter. T for top parts, they are both identical, L for left to be placed at the bottom, and R for right, also on the bottom. It's time to slot the whole X and Z axes into position. Keep in mind there's a lot of wiring now, so position it in a way that it won't interfere. The guides must pass through the upper holes, so you must slide the ensemble in beneath. Pay attention to the orientation of the X-axis and the indications on the printed parts. Once you are sure the assembled axes are well placed, use the screws indicated in the manual to fix the printed parts to the structure. Tighten them firmly now, including the screws previously left loose on the 3D printed parts. Remember to see if the axis components slide freely. The following step is to place the threaded rods into position. Each rod should slide in through the x-axis between the 3D printed guide tips and the vertical guide bearings. The rod then continues to tighten downwards and inserts into the flex coupling. Keep screwing in until the rods touch the stepper motor shafts. Before fastening the rods, measure the distance from the x-axis metal brackets to the top of the stepper motors and see if the distance is exactly the same on both sides. This will come in handy later. You can change the height of the x-axis by twisting the flex couplings. Once the distance is the same, fix both couplings in place by tightening the socket set screws inside the couplings.
With this done, you must now check if the nozzles are not coming into contact with the build plate. If they are, rotate both flex couplings at the same time in a clockwise motion. You need about 8 mm of clearance since you'll be adding the glass plate later. Onto the drive belts. You have a single coil that you need to measure out and cut. We start with the y-axis belt. Thread the end of the belt drive into place as you see here. Note that the belt has an orientation. When it's looped around the pulleys, it must have its teeth facing inward so as to have traction on the tooth pulley. The belt's tips are held in place with cable ties. Consult the manual to ensure you use the correct ones. Once fastened, cut off the tip of the cable tie with cutter pliers. Loop the belt around either pulley. Stretch it and then cut it. use the build plate edge as the reference for the cut. Then fasten the end onto the bracket just like you did with the other end, apply a cable tie and cut the excess of both the tie and the belt. You now tension the belt by carefully pulling on the stepper motor and tightening the screws. If they've been tightened, loosen them first, stretch the belt and retighten. The belt must have some play in it and not be too stretched. Do exactly the same for the X-axis drive belt. First you apply these small components on the X-axis. You may need to file away spots of thick paint. Loop the belt tip, making sure the teeth face inwards when looping the belt, and fasten with a cable tie. Loop the belt around the pulleys and fasten the other end. Note the two small metal plates are held in place by the tension belt. To finish, stretch using the stepper motor, then tighten the motor screws. This phase of the assembly is now complete.